In this video, we'll go through the answers for the Flashback Friday from November the 6th. In the first question, we have two vector lines that we are told meet at a point. If this is true and they meet at a point, then a sketch of the situation will look something like this, and they meet at point C. To find the location of point C, we set the equation of vector line 1 to the equation of vector line 2 and solve for the unknown parameters lambda and mu. Line 1 is 2, 3, negative 4, lambda 1, 2, 1, and that is equal to 0, 9, negative 3 plus 5, 0, 2 mu. When making two vector lines equal to one another, you can set up three simultaneous equations for the I, j, and k components respectively. So that gives us 2 plus lambda is equal to 5 mu, 3 plus 2 lambda is equal to 9, and negative 4 plus lambda is equal to negative 3 plus 2 mu. We then solve these three equations simultaneously. Any pair can be used to do this, and you can check your answers in the third equation. The center equation gives us a very convenient value of lambda equals 3. Since there's no mu in that equation at all, it's the easiest to solve on its own. We can then substitute lambda equals 3 into the top and bottom equations, and in both cases we get mu is equal to 1. Since all three equations agree on a value of lambda and mu, these will be the correct parameter values for the intersection between the two lines. When mu is equal to 1, the point from the right hand side of the equation will be 5, 9, negative 1. And this is therefore our coordinate of C. In part 2, we then have to work out the size of angle ACB, where C, the intersection point previously discovered, is where we have placed on our diagram. A is a point on L1 where lambda is equal to 0, and B is a point on L2 where where mu is equal to -1. The angle then between A through C to B is given through the dot product of the two direction vectors of line 1 and line 2. Line 1's direction vector 1, 2, 1 and line 2's direction vector 5, 0, 2 can then be used in the dot product or in the scalar product formula in order to find the angle between the two lines. The dot product formula says that the individual lengths of the two direction vectors multiplied by cos of the angle between them must be equal to the dot product of the two vectors. In this case, the dot product has a value of 7, 5 plus 0 plus 2, 5 times 1, 0 times 2, and 1 times 2. And so we do 7 divided by our lengths of each of the direction vectors in order to calculate the value of cos theta, and therefore the value of theta itself. In the final part of the question, we're then asked to find the area of the triangle. Completing my sketch, we have the triangle ABC formed up here in the top left-hand corner. Triangle ABC is a non-right angle triangle, or at least we should assume that it's a non-right angle triangle, in which case we should use the formula a half AB sine C in order to find its area. The A and the B and the C in this case refer to the length between B and C, the length between A and C, and the angle theta that is between the two of them that we have already calculated at C. You can in theory use any of the angles, but it makes sense to use the angle we've already bothered to calculate in part B. In order therefore to calculate this, we need to work out these lengths little a and little b, which are the lengths between B, C, and A and C. To do this, we need the actual coordinates of A, B, and C in order to find the length of the vectors between them. C we have already calculated in part A as being 5, 9, negative 1. A is the coordinate 2, 3, negative 4, which is the value of the first line when lambda is equal to 0. And b is equal to 10, 0, 4, which is the value of the second line when mu is equal to -1. The length of AB is then given by using the Pythagoras formula. The difference between, sorry, we don't want AB. The length from A to C is then given using the Pythagoras formula by looking at the difference of the two coordinates, squaring them, adding them, and square rooting them. So that gives us 3 squared plus 6 squared plus 3 squared, all square rooted, giving us 3 root 6 overall. And then from B to C, which is the second of the little lines, the same result will give us 10 squared plus 0 squared plus 4 squared. Giving us 2 root 29. We can then apply these into our calculator to calculate the area of the triangle. 1/2 multiplied by 3 root 6 multiplied by 2 root 29 multiplied by sine of the angle found in part B. A value you should store in your calculator so that you can get exact value answers in this final part of the question. And this comes out rounded to 33.5.